We're going to try to solve the circuit using mesh analysis. The first step is to make sure that the network is a planar circuit, and it is. Second, we need to withdraw if is needed, and if we need to withdraw, we will have to do it in a multi-panel window. Then third, we need to indicate all the elements and sources values, and we see that we have all the sources like a voltage source, 16 volts, and all the elements have values. 4, we will need to assign a clockwise current to each mesh. So mesh 1, we assign current I1. Mesh 2, we assign current I2. Mesh 3, we will assign current I3. Next, have to check if we have current sources in the circuit, because for mesh analysis we cannot have current sources, so we have to erase those or remove those from our circuit. And the next step is to draw a super mesh if we have a closed loop. So if you can see on mesh 2 and mesh 3 it is an open circuit, so the only super mesh that can be drawn is at mesh number 1. And this will allow us to write Kirchhoff's voltage law equation, and then if we have dependent sources we will have to write equations for the dependent sources. Now we're going to write the Kirchhoff's voltage law equations around the loop, and if you remember we have only one loop, that's in mesh number 1, but we still need to use the currents I2 and I3 when we write the equation. So to write the equations we will start with the voltage source 16 volts equal to the other voltage drop, that is 2 ohms times ISO1, followed by a voltage drop across the 2 ohm resistor, that is ISO1 minus ISO2, and the next one is the other voltage drop, 2 ISO1 minus ISO3, and then the last resistor on the loop is 2 times ISO1. Then this will be equal to 16 volts, 8 ISO1 minus 2 ISO2 minus 2 ISO3, and this will be our equation number 1. Now we're going to write the equations of the remove current sources. So the first one, we see that for this we have that ISO3 is in the same direction as the current on the current source, so ISO3 is equal to 2 amps. For the next equation, we see that the dependent current source is in the direction of current ISO3, so we will write ISO3 minus ISO2 equal to 4 I sub x. Now I sub x, then for equation number 3, we see that I sub 1 is in the same direction, I sub 2 is in the opposite direction, so we write I sub x equal to I sub 1 minus I sub 3. And then we can write both equations, and I sub 3 minus I sub 2 is going to be 4 I sub x. We found I sub x to be I sub 1 minus I sub 3, so 4 times I sub 1 minus I sub 3. I sub 3 is equal to 2, so we can replace that value into the equation in order to give us 2 plus 8 equal to 4 I sub 1 plus I sub 2. Then this is equal to 10, 4 I sub 1 plus I sub 2, and this is our equation number 3. Now we have the 3 equations necessary to solve the system. To solve the system of equations, we write equation number 1 as 8 I sub 1 minus 2 I sub 2 equal to 20. Equation number 2 was equal to I sub 3 equal to 2. And then equation number 3 was 4 I sub 1 plus I sub 2 equal 10. If we solve for I sub 1 and I sub 2, we find that I sub 1 is going to be equal to 2.5 amps. I sub 2 is going to be equal to 0. I sub 3 was giving us 2 amps, and so combining I sub 1 and I sub 3 gives us I sub x as I sub 1 minus I sub 3 equal to 0.5 amps.